So, first thing we need to do is install the development tools. I do have a person who's going around who is the TA, by the way, who has a USB drive, who will come to your computer, hopefully not everybody all at once, and install the stuff for you. But let me just talk about what we need to have installed. If you already have Java installed on your computer, leave it alone. If you have a MacBook, you have Java on your computer. You know you have Java on your computer, and you know the Java is working when you type in Java C, and you get something like this that comes up. So if you want to see if you have Java on your Mac or on your PC, open up a terminal prompt on your Mac or a DOS prompt on your PC, type in Java C. Make sure you're typing in Java with a C at the end of it, not just Java, because we need the JDK as well as the JVM. So Java is the virtual machine. So if I type in Java, I'm going to get both. So I'm going to have both, but Java C is the one we want. It's the compiler. Eclipse uses it for the Android SDK. So if you don't have that, it's an easy way of getting it. I seem to have access, so I'm going to go ahead and continue here. If you don't have access, don't worry yet. If I go into I just opened up Eclipse, excuse me, I opened up Yahoo, or Google actually, and I typed in download Java. Brought me to the screen. This is not the Java that I want. I want the JDK. So I'm going to type in download Java JDK. 1.7, I believe, is the downloaded version that you're going to want. Oops, now it's working. See, my connection is working. I don't know. What we want to install, if you do not have Java installed, because we don't care what version it is. You might have an older version of Java on your computer. No problem. It will work with anything. If you have a MacBook and you type in Java C, it might prompt you to install Java if you don't have it. Go through that install it from the Apple Store or from the Apple concept instead of doing it this way. If you're on a PC and you have internet access, actually, has it come? It's working for me. Is it working for everybody else? It's come back? Okay. So if it has come back and you have it, then what you want to do is click on the link here that says Java Platform Jdk. So let me zoom in a little bit here so you can see what I'm talking about. JDK is what you want. 7U17. So it's really version 1.7, well, 2.7. Well, don't worry about the versioning. This is the one you want. Here, you don't want the FX version, you don't want the NetBeans version. So if you click on this version here, you have to accept the license agreement. You have to know what kind of PC you have. Is it a 64-bit or is it x86? Depending upon what version, you have to install the right version of Java. So you have two choices. On the USB disk I gave you, we have both of these two downloads on there. So why don't you become mobile and offer it up to anybody who might want it right now. So if you don't have an internet access, if you have internet access, go ahead and start downloading it right now. If you don't have internet access, your second choice is to get it from that disk that she has right there. So I guess raise your hand. We have a couple. Maybe start from the front of the room and go backwards, maybe. Just put on the version that you might need. So, if you already have it installed, you don't need it. And hold on, let me pause this for a second. Okay, so I'm going to sort of move ahead, but we're going to catch up at the break. So if you have a problem during the installation, hold that thought. We're going to have a break in about an hour, and I'll spend a few minutes to troubleshoot everybody's problems if you haven't figured it out by now. So if you're on a Windows system and you don't have Java, you're downloading one of these two items right here. And it's going to take a few minutes for it to download. When it downloads, you're going to have to make an environment variable change to add Java to your path. And I'm going to show you how to do that right now, actually. I have a Windows system on here. You do not have to do this for Mac. So if you're on a Mac system, you can tune me out right now. You don't have to do any of this. It's a lot easier for you. You just
have the problem with path setup.
Yes.
Java, but
I'm doing it right now.
okay.
So
that, and then I'll go with this at least.
do they have Java installed?
Yes.
Okay, no problem. So what I'm going to do now,
Let them try the path and still they don't get it. So
okay, what I'm going to do now is open up a Windows virtual machine on there. I'm actually going to open up XP because it's very similar to 7, which is what most of you probably have. 7, or if you're on 8, it's going to be very similar steps as well. So I'm going to open up a virtual machine here, and for you Windows people, show you how to set your path correctly. If your path's not set correctly and you've downloaded it and you've run through the install, because once you download the file you have to double click on it, run through the install, then you have to change your environment variables in order for that javac command to work at the DOS prompt. And that's a critical step, and you may also end up having to reboot your computer after you've made that step in order for Java to be recognized. You need it to be part of the environment variable so that Eclipse can pick it up and use it. So what do we have going on here? Loading up Windows XP. It'll take a few seconds here. Okay, so now I have a Windows system on my Mac system. And if you haven't heard of parallel, actually if you have a Mac and you haven't heard of parallels, you can have 3 systems. Actually I have 3 systems in one. I have a Windows 8, an XP, and a Mac system all here. So it's great for troubleshooting. Go to a DOS prompt. The concept is the same. You type in javac. I actually have it in my path, but I want to show you what happens when I take it out of my path. And I'll show you what I mean by the path. So if you're on a Windows 7 system, you're going to use a slightly different way of getting to this. Or if you're on a Windows XP system, you can use these tools. Or if you're on a Windows 8 system, exit to the to the desktop. So you're at the desktop system. Then you're going to end up having to find something or run something. You're going to run system from the control panel. So I'm going to hit on start, and I'm going to go to my control panel from my start menu. You might have your control panel from a different menu depending upon how you've got your Windows configured. And then I'm going to double click on the system icon. So I'm in Windows, I'm in the control panel, and I'm clicking on system. In my system icon, well, the screen will look very similar to 7 and 8. Actually, it's compatible. Actually, it's the same utilities you got in XP. It's the same thing, it just has a different motif on it. I'm going to click on the Advanced tab. So the one on the top of the screen here, it says Advanced on it. Click on that tab. And then on the bottom of the screen, it says Environment Variables. I'm clicking on Environment Variables. And in my Environment Variables, on the screen that's on the bottom of the window, there's one here that says System Variables. On the bottom here, I have Path. And I'm going to click on Path. So you have a couple of them here. I see path EXT. I see path. I don't know. If you make it bigger, you can see a bunch of other stuff. Just the plain old PATH. Most likely you have it. If you have other software installed, you have a path entry. Click on Edit. You see at the end, I have a directory in here. I'm actually going to cut this out real quick. Show you what happens when I take it out. What I'm adding to the end of the path, let me put it back in so you can see it, is program files Java Jdk 1.7.0_11, which was at the time that I installed it on this emulator. It was _11, and then I have the bin directory. If you're concerned to see, well, do I have Java installed, go to your File Manager. So I'm going up to Windows Explorer for File Manager. I'm going to open up the C disk. I'm going into Program Files, and I'm going to hit Java up here at the top. So I've got Java. And you can see here on my screen I've got a JDK 1.7.0_11 directory. Yours might look different. Yours might say _14 or 16 or something. I don't know, something bigger, because this is a couple months old. If I open this up, I see bin. In the bin is where my javac command is. This is what I'm adding to the path to make it available so that I can type javac from anywhere on the computer and it will come up and be recognizable. So let me show you what happens when I take it out of the path. For those non-believers who think that that's not the problem. It is the problem. Watch this. If I take it out of the path, I'm cutting it out and I'm going to save it, and I'm going to save it. So I just broke my system essentially. Now I go to my DOS prompt and I type in javac. Javac is not recognized as an internal or external command operable program or batch file. If you get that, I'm going to go back in and fix it now. Now that my system's broken, if your system is doing that after you install Java, then go into the control panel, click on System, click on the Advanced tab, go down to the bottom where it says Environmental Variables. It's going to look the same whether or not you have 7 or 8. In fact, the tabs might be in slightly different locations, but the tab names are identical. Click on the path that's right here. Edit the path. Leave the contents of the path there. Do not remove what's in the path. Put a semicolon at the end of the path because you're going to append the new path. And the new path that I'm appending here, I'm going to paste it back in, is c:\program files /java /jdk 1.7.0 _11 bin. Make sure you have the complete path to the bin directory from C or from D or from wherever you have it. Add it to the path, so I'm pressing on OK. And then I'm pressing on OK again, pressing on OK again. Now I'm going to go to the DOS prompt. I'm going to type that same command back in again, java c, and lo and behold, it works. It's instantaneous. This works this way for XP. For Windows 7, you might have to reboot your computer. Depending upon what kind of security you have, if you have a firewall system installed, if you've got... I don't have anything installed in this system, that's why it works like this. You might have to reboot your computer and log in as the same user that you were before, yada yada, for your system to work. That's the only thing that will fix this problem. You have to add it to the path. Once it's added to the path, you can now use Java. But that's useless. Well, not useless. That's only half the tools. So we need to install the Android SDK in order to get the rest of the tools that we need. So once you have Java installed, you're great. You can just leave it alone. Part 2 is to get the JDK installed. There's 2 different ways of doing it. There's a long way and a short way. The long way is to go out to the Eclipse website, download Eclipse, go out to the Android website, download the Android SDK, install the SDK inside of Eclipse, go into Eclipse, and then update it. If you already have Eclipse installed on your computer, it makes sense to sort of do that. At this point, however, you can install a different version of Eclipse that has the SDK already in it. So in order to do that, we're going to go to the Android SDK website, which is developer.android.com /SDK. So android.developer.com SDK. Actually, if you leave out and just put in SDK, it'll go to index.html for you automatically. So it's just developer. It's kind of like developer.apple.com. It's developer.android.com. I wonder where they got that from. /SDK. And then when we get there, real easy, there's a button over here. If you're on a Mac system, click on the button because it's going to say it's for the Mac. If you're on a Windows system, if I go to that website over here in my Windows desktop, it'll show me the options for Windows. So let's see, developer.android.com SDK. It's running a bit slow, but I got access still. It says download SDK ADT bundle for Windows. Sounds like someone's running my recording. It's okay. It's okay. It's okay. No.
Actually, I'm watching a video made by you.
Okay, good. Yeah, if you're having problems, you can do like what he's doing here, and there's videos actually recorded on YouTube. I'll show you those in a few minutes that will help you also install it. If you can't get it installed right now and you want to hear my instructions all over again, I'm just giving you a different version of the instructions right now. But you can get the SDK here. Down on the bottom of the screen, you still have to agree, but then you want to download the 32 or the 64-bit. If you're having problems downloading it, it's also on the USB disk. When you download it, you double click on it, you run through the install of it, and it'll put this little button down here. The little button says short, well, it won't put it down here, it'll put it in here. After you install it, you can, it's basically a directory. You can drag the directory to your file path location. Let me show you where mine is actually right now. It's a zipped file, by the way. The install is a matter of unzipping it. When you unzip that file that you're downloading from the SDK, you take and you drag it over, and I stuck it, program files, I probably stuck it in here. Where did I stick it? Here, I can find out real quickly, actually. I stuck it in it's right off the C drive. So, here it is right here. This is the name of the folder that I got. I installed it on an x86 emulator, which is what this is. This is not a 64-bit, it's an x86, 32-bit. It's in here, and actually, it's kind of sloppy because it's in here, And I dragged it over here, and I stuck it right off the root of my C drive. So when you unzip that file, you're going to get a folder. Take the folder, drag it over to your file manager, stick it right off the roots. If you look in here, you'll see there's a bunch of subdirectories. There's one directory called Eclipse. In Eclipse, you got a purple bubble that looks like that. Make a shortcut for it, stick it on your desktop. If you don't have a purple bubble, then you have a green bubble with a black outline. Possibly. But let me show you what I mean. So when I start up Eclipse, and if I've downloaded the complete bundle, I get this black screen with green writing on it. It says Android Developer Tools. In a few minutes, I'm going to start up my other one. This is going to take forever to load. Well, it shouldn't take forever. It's loading. It does take a few minutes. You see in the bottom here, this is loading up.
Can you get the pen drive?
Yes, you may. When you get a chance, they needed the pen drive up here.
I just we did for one person install and check the Java and Java.
Oh, okay, perfect. Yeah, you can troubleshoot. Can you troubleshoot those problems with the environment variable? She can also troubleshoot environment variable problems as well if you're having problems running Java C.
I'll come from back.
Okay. Please be patient. We only have one TV, one TA. Don't worry about it. I'm not going to run anything at this point until everybody's installed. So we're good. If I open up Eclipse from the bundled download, on top it says Java ADT on the top of it. It's a special version of Eclipse that has the Java and the SDK installed in it already. If you made it this far, there's still one more step that you're going to need to do. If you click on the window, you'll see where it says Android SDK Manager. Open up the SDK Manager, and this will also require internet access, by the way. You'll see in the right-hand side under Status, it says installed, installed, installed. Oh, now there's an update available for me. I'm not going to use this one, so I'm not going to run the update. But you may select a few of the SDKs to install. What are these going to be? These are going to be the different support, the different bundles. For today, for most of what you're going to do, you can work with the current. It might already be installed by default. It may not be. You might see updates here. What you do is you click it on the left-hand side of the screen over here, and then you click the button that says install all 6 packages in my particular case. Update your development support. If you update development support, then you can build projects for all of the different Android versions. If you go down to the bottom here, you'll see it goes down to 1.5. I don't have 1.5 installed. Actually, I think I stopped at about 4.2 on this build here. I don't even have the rest of it installed. But if I open it up, it says not installed, not installed. So if yours is all closed over here, it might look like that. Open it up, expand it out. You want to have at least one version installed. It doesn't matter because everything's backward compatible. Not like the iPhone where you have to have every single SDK version installed. What is this? This is the tools. You need the tools. If you don't have the tools, you can't use the AVD Android virtual device, which I'm going to show you in a few minutes. But what we have here is just the SDK platform tools, the regular tools, and then these are all the SDKs. So I'm actually going to run, for the purposes of my examples, I'm going to bring it back down to a 2.3.3 version. Why? Because it runs faster. When we start, and it's compatible, for the most part, 99% compatible with some of the higher ones, all the way up to 4.2. We might even have something higher in 4.2, I think. I'm not even quite sure right now what the current version is. But you know, you always see these different versions. You know, have ice cream versions, and you know, all of these. They're all names associated with 4.2, 4.1, all of the different versions of the SDKs. They all have names on them as well. There are no names in here. Instead, what you get is the numbering system. 2.3.2 is fairly compatible. Actually, that's what's out on the market for most devices. I have a Samsung device that runs that, and it runs it beautifully. So, and I leave it alone. I haven't upgraded it. So it's not like you have to upgrade. In fact, some devices this is not upgradable. So I run it. I'm sorry?
What's the latest version of SDK?
Well, according to my downloads, I got 4.2. I thought there was a 4.3, but it might be in beta. So it doesn't really matter if you have the latest and greatest, especially for the purposes of using the emulators. You'll notice the earlier ones run faster. So it's not, there's no benefit outside of being able to use the new features of the SDKs. But what we're learning this weekend, you can use the new features or the old features. So it's all going to be compatible. So as you're sitting around idly waiting for something to do, go ahead and update your SDKs at the same time. Yes?
I already got the Eclipse EE version, Indigo.
Okay.
Indigo is different than this one.
Yes, it is. Let me show you something else. If you have I'm continuing with that. That is the instructions for the downloaded Android bundle that has the Eclipse and the Android SDK bundled all together from the developer website. If you don't have that and you already have Eclipse, then let me show you, because it's going to be on my Mac side. This is what I did on the Mac side. I also have Indigo. So I'm going to close down this XP VirtualBox.
Windows 7.
Windows 7 is going to be the same. The instructions for the Eclipse version are going to be the same for the Mac and also for the PC. So now in my Mac side, I have I have Juno. I used to have Indigo. I have Juno. You might want to upgrade to Juno, actually.
Yeah, I have both of them.
Okay. If you have Juno, do you have the version for Java, or is it the version for C++?
It's Java.
Perfect. Perfect. You need to open up Eclipse. So if you're going to install it manually inside of an Eclipse version that you already have, the steps are different.
The Indigo?
Open Indigo. Open up Eclipse. Yes. If you already have Eclipse installed, open it up.
Instead of like Java ADT, I'm getting Java Eclipse SDK.
Yeah, you're gonna get something that looks like this on the top here. Yeah. It's just not blank. It's just not packaged under ADT. It's packaged differently. If you have downloaded, or if you'd like to download, you can download. It's also, the instructions are also printed in the first tutorial. So let me show you the first tutorial, because you can cut and paste out a tutorial for what you're going to do. You're going to basically create a download site, download the Android SDK, and the plugin, install it into Eclipse, take the plugin, and then install the SDKs inside. So you don't have to reinstall it. So come on out to the bhacker.com website. If you're going to do this, it's easier to cut and paste out of this document. Go into Spring 2013 Android phone application development. What we want is tutorials, and we want the Hello World tutorial. So download this one or open it up. It actually runs through the install, believe it or not, because some people haven't made it this far. Oops, actually this version is not going to do it. I edited it. Oh great. Hold on one second. Let me just make sure. No, it's an ADB. Okay, I apologize. This one's not going to do it. It's the earlier one that's going to do it. Hold on one second. I have it printed here so you don't have to type it. You can great. Hold on one moment. Actually, let me pause this for a second. I'm going to have to direct you to the tutorial. I don't have my notes for this because I'm not encouraging anyone to do this anymore because it's so much easier to install it from the Eclipse package. But here's what you do, actually. I have it in one of the videos, and the video that it's in is out here. So you can do one of two things. You can watch the video for it. The video is going to be, oops, well, no, the internet's not going to work. The video is going to be right in the beginning where it says install Java, install Android, install Eclipse, install the Android tools. Let me just tell you the basic steps because I can't get to it right now. When you have the plain old Java up, what you're going to do is go into the Help menu, install new software. You're going to add a link, and the link you're going to put in is for the JDK, excuse me, for the SDK, the Android SDK. You stick the link in here. It's a HTTP blah 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 blah. That link is what's in the instructions that I was trying to look for a few minutes ago. It's also, but it's in that video actually. But I don't have those instructions because I wasn't planning on having you guys do this. If you go out here, actually, you can probably Google it if you can get. If you get, so let me see, Android SDK into Eclipse install. Let's see. Well, there's a link. Did you find the video? Okay, good. If you found the video, you got the link in the video. You put this in here, you press OK. It adds a new thing for you. When you update it, it gives you all the buttons to press on for the SDK. You press on the buttons, you install the SDK and the plugin, and then you go and you'll find out that you have, once you've done that, then you'll get new menu options. And the new menu options you get are these guys right here. So once you install, you have to install the plugin, which is what you're getting from that install new software. But you need the link, you need the URL to put in there, which is in the video.
Yeah.
So if you do that, you come down here, it's the same process as before, you're at the same point. But what you're doing when you download the bundle completely is you're getting everything all in one. You don't have to install the plugin inside of Eclipse. But you're getting a special version of Eclipse that's designed for the Android toolkit. So in this particular case, you're going to use an Eclipse that's already in existence that you downloaded for something else, that hopefully has Java support, that you're going to install the plugin into, and then from the plugin and you install this, you'll get this menu. So then you install the rest of it. I don't recommend doing that, especially if you don't have Eclipse installed yet, because it's more work, it's harder. If you already have Eclipse installed, however, you can put another version of it in, because the Android version of it will be totally different. So you might, even if you have Eclipse, you might just leave it alone. Download the one from the Android SDK site, unzip it, stick it over. It's not going to change your current Eclipse. It's not going to update it. It's not going to do anything to it. You can have multiple versions of Eclipse on the same computer. Different directory. Yeah. So I actually think it's a lot less work to do it that way, and a lot less complicated. But I don't know. I'm sort of a minimalist, and I use one version of Eclipse for everything. I got C++, I got Java, and I got Android all in one. But that's because I don't want 5 different versions or 3 different versions of it. But for your purposes, especially for right now, for today, it's probably easier just to download the SDK and install it, so from the bundle. So, and that I wasn't planning on showing you how to do it, so I don't have the notes in front of me. But there is a video on that. So once you have it installed, depending upon how you have it installed, you're going to have more options on the window here. So what do you get when you install this? You've got an IDE, which is a graphical user interface to the Java C. So instead of at a DOS prompt typing in Java C, you're going to Eclipse and you're using menu items, GUI, to install things and create projects and stuff. You also have the project concept. Can we keep the volume down in the back? We also have the project concept that I'm going to go over in a few minutes. But I'm going to sort of do this a little bit out of order, but before I do it, I want to see how many people are still having problems installing. Raise your hand if you don't have your computer set up yet.
My internet connection is
I know, my internet connection is working now. I'm sorry?
We started Java, ma'am, but we are trying to download Eclipse and Sdk. They have few students have problem with that.
Okay, so I'm going to delay the use of the tools until we have everybody on speed here. So instead, I'm going to talk about Android and give you a few background information. So I'm going to show you some boring. No, I shouldn't say boring. I'm going to show you some lecture stuff because I'm killing time so that we can have essentially most of the people in the room up to speed. So I apologize if you already have your system set up. We can't really go forward right now. We have to wait. So I'm going to give it maybe about an hour. Let's see what happens here. If you are having problems, the TA is going around and she's providing some assistance. I will also provide some assistance when we take our first break. But in the meantime, the internet, I believe, has come back up. It could be going down again. I'm sorry? It's very slow. That's because people are using it. In fact, we're not the only class going on today as well. So, did you have a question? I saw a hand come up. Yes? We have.
Not able to download or install Eclipse and
It's on your disk. It's on your USB drive. It's on the USB drive. So, if worst case scenario, you gotta wait for the USB disk to come around for you.
so in this USB we have Android as well?
We have everything. Everything's on that disk. Java, Android, and SDK, and Eclipse. Everything. Everything. The entire toolset can be installed from the disk on a 64 or a 32-bit Windows system. There's also the Mac on there as well. For anyone who has a Mac, the Mac tools are on there too. Yes.
Did you recommend if we already had Eclipse installed to not configure it through that install already, instead just do it through the Android SDK bundle?
Do it through the Android SDK bundle for now. You can always delete that folder. It's easier. Plus, you know, given all of the internet system issues we're having right now, I would say it's much easier just to install that one pack. If you can get that package installed or copy it from the disk, because the SDKs that you're uploading, the information that you're getting through the update concept is a lot smaller. It's a lot easier to do. The plugin for Eclipse is big. It's bigger. So. There is a way, just know in the back of your mind, there is a way of setting up your existing Eclipse to work with the Android tools. You don't have to go with the new bundle, but for right now, I'd recommend going with the new bundle. All right. So let's begin. And we'll take a break in about, I don't know, a half hour or so. I'm going to go through a little introductory stuff, talk about the platform, give you some background concepts while we're still getting everybody up to speed. So you're looking at lectures that can be downloaded from the bhacker.com website as well. So I want to talk about Android a little bit, talk about what we're doing, give you the foundational material so that when everybody's up to speed, we can start in with the first and start building some projects. And if we could keep the volume down, it's irritating to people that are sitting around you. It's irritating to me too. Sorry. Okay. The hallway is actually a pretty good place to troubleshoot problems as well if you need to have conversations and stuff like that. So let's take a look at the platform. Hopefully at this point you know it's by Google. So hopefully at this point you know it's been around for a while. Hopefully at this point we have tablets. We also have phones on the market. They're all Android enabled. And it's through an open handset alliance that this came about, actually. So business alliance consisting of 47 different companies developing open standards for mobile devices. So when you compare this to iOS, as an example, iOS is not open. iOS is owned by Apple. So we have the iOS platform, which is their own platform, proprietary platform. We also have their own market, Apple Store, and it only works on Apple computers. If you've ever tried, it's like some people have tried, you have to put an emulator on your Apple computer if you're going to do any, excuse me, on your Windows computer if you're going to do any Apple development. Now we have third-party tools out. Third-party tools such as PhoneGap and some of the other ones that allow you to write applications on a Mac that work on an Android, write applications on a Windows system that work on a Mac system, and we have this cross-platform kind of goal in mind, but you're using a third-party tool. You're not doing what's called native application development. So this class is all about native application development. It's all done in Java, and it's all done through Eclipse, and the emulators, what we're going to see as soon as everybody's up and running, are all part of the Eclipse package and the Android SDK. So it's all done. It can be done on any computer you want. It's open source, which means anyone who wants to can write stuff. So I have, for testing purposes, I have a Samsung Galaxy tab. You don't need anything. Actually, your phone works, though. If you have an Android device and you have a cable that came with the device that connects it to the USB port of your computer, by the end of the day, you can actually install your application on your device. Well, we're just probably going to hopefully get through a hello world, but you can put it on your device. It's easy because it's open. So you can't do that on some of the other development environments like iOS because it won't allow you to. You have to put it into the store and download it from the store. And then if you want to run it on your device, you have to go through an entire development license and provisioning and pay them $99. And there's a added fee to that. Well, there's also an added fee to the Google Store, Google Play, that you'll also have to inquire about, which will be between $49 and $99, I believe. I think it might be like $49 or $69 at this point. Keeps going up. Used to be free. So Google Play is the market. No license, no waiting period, no provisioning, nothing. You just upload it and other people download it and it shows up instantly. In the iOS market, you've got clearance. You know, you've got, they actually look at your app, they approve it or they disapprove it. A little bit stringent, higher quality, theoretically. It's not open. So you get a big difference. So it's easy to remember that Android is open, and what I mean by open is that because it is open, it has pros and cons. Con, hard to do quality control. In fact, how are you going to make sure everything goes through a store? You can't. So sometimes you go to websites and you download what's called an APK file, application file, that you download it and you can, actually as soon as you download it, you can just click on it, install it on your Android device. No quality control. How do you know that it has something in it, like a virus, or how do you know that that's not going to do something bad on your computer or something? You can't. Well, so there's a little bit more trust with the Apple Store because that won't make it into the store if it's a bad app. So that's kind of like one of the cons. One of the pros is that every manufacturer now of the hardware can build a specialized JVM or a specialized Android version to work with their device. And I mentioned the Samsung device only because if I go into, and I'm not going to do it right now, but if I go into my Eclipse and I look at it, I have Samsung SDKs. And you can get things from Motorola. So the hardware is different for each one of your Android devices. It's not consistent hardware like what you get on the iOS device. iOS device is all controlled. One set of hardware, predictable. Android, not so much. So again, a pro and con associated with that. Because it's not consistent, you have to pick up sometimes drivers and pick up SDKs and add on utilities for each one of these different devices that you're going to run it on. So when you create an Android app, you're specifying the device and the version of the Android SDK that you're running. What operating system are you going to compile for? We can compile in range, however, and it will work on everything. So as I was mentioning before, 4.2 gets installed automatically for you. Who's got a 4.2 device? I've actually never seen a. Oh, you do? Okay, good. Did you just buy it like within the year?
No, I got a Galaxy Nexus and
Oh.
I got the,
Oh yeah, that has it. Yeah, the Nexus does, yeah. Anyway, I don't have one yet. Usually, you know, if you keep a phone for a couple of years, keep a tablet for a couple of years, you're going to be on an older version. You're not going to be on the newer version, unless the device is upgradable. But long story short, I like to actually work with some of the older SDKs because then, you know, I know it's compatible with more devices on the market. So, which is kind of interesting because it's the exact opposite of what Apple does. Apple wants you and forces you to actually work with the latest and greatest. So you can't go backwards. So there's a little bit more freedom in the Android market, just say that. So who's part of this? Well, we got the headset manufacturers, mobile operators, software companies, semiconductor companies, commercialized companies. And here's our Samsung here, our Sony, Motorola, actually just complete DroidX utilities as well. So usually you're going to pick a device, or you're going to pick some support you're going to work with. If you're going to do it this route, maybe download the modules for it. And if you go into, I'm not going to bring it up, but if you go into that window, if you're updating right now, you'll see some stuff. Don't pick the special stuff in there, the Motorola stuff, unless you really need it. And some of it's a little bit outdated. HTC is another one that's popular, yeah?
So when we create an app, we have to create for each and every device?
Nope. You create one and you use it on all. However, if you're doing something that's specific to the hardware of the device, you have to select the right device packages and the right device, which is different from the iOS market. iOS market, every single device has the same hardware on it. So as a classic example, the camera on this Samsung device is different than the camera that's on a Motorola device, which is different than a camera on an HTC device. Well, that's just the camera. The microphone's different, the Wi-Fi is different, everything's different. It's like all your PCs out here are all different, which is kind of, you know, unique and great because it's open. It's open alliance. But the problem is you're writing something that works with a camera. So the problem with the Android development environment is sometimes the hardware is going to dictate what you can and cannot do, and sometimes you'll end up having to be more generic in terms of supporting certain speeds or certain functionalities, so that it does work on multiple devices. Or you can take the other route, build it for one specific device, because we do have some utilities. In fact, every time you buy a device, you buy a DroidX, you're going to have a Verizon. Verizon service, you're going to have Verizon apps. You're going to have DroidX apps that are specific towards that device, that are written just for that device, that don't work on other devices. So, which is the interesting thing with the Android market. And just pointing out that we don't have one consistent platform. So you really are creating for multiple platforms. Here's some tablet versions of it, Cisco tablets. Some of these are kind of outdated, but not really. Some of it's still around. Let's take a look at the architecture. So how can you make one app work on 5 different pieces of hardware? So it's the same thing reason why, because on day 1 of your Java course, whenever you took Java, if you haven't taken Java yet, this is your day 1 of your introduction to Java. You're not running it on the hardware. You're never running it on the hardware, which is how you can make one app work on 10 different devices that are all different from different manufacturers. Because you're running on what's called a JVM, Java Virtual Machine, but they have a different name for it. It's a actually, I think it's probably in here, coming up. Well, it's equivalent to the JVM. Here it is. It's a DVX, Delvic Machine, DVM, Delvic Machine concept. So I'm going to go back to that slide a few minutes ago, but just to kind of skip ahead, kind of show you what the concept is. If you've done any Java development, the first thing you realize is that you don't get an exe file. There's no such thing as an executable file. Instead, you have to install the Java Runtime environment, which is called JVM, and you install the Java compiler, which we just did, or some of you are still doing right now. So you type in javac, you take a .java file, you turn it into a .class file. You take and you run that class file by going java space the name of the class file, and then it runs. Well, what does it run on? It runs on my Mac, runs on your Toshiba, runs on his Dell system, runs on everything. All different hardware. Because it's not running on the hardware, it's running on a virtual machine that's on top of the hardware. Same concept here on my computer, actually. I have Windows 8 and I have XP on here. Actually, I skipped 7. I used to have 7. I updated it to XP. But long story short, not running on my hardware. It's running on virtual machine software that's installed on the hardware, installed in the operating system that's running it. That's the basis for how all of Android works. Different than iOS. iOS, you get an executable file. It's running on the exact hardware that it's built for. You can't take that and run it on another. You can't take it and run it on a non-iPad or a non-iOS device. It doesn't work. Did we have a question in the back?
Yes, ma'am. When you're trying to download that bundle and
Uh-huh.
normally we have to download that in the program file because it's not allowing us to extract that.
All right, I apologize for that. Let's go back, at least get through a couple of concepts here before we take our first break. Save all your questions for the break if you wouldn't mind. Thank you. So we have the same concept that works, and our compilation process is doing the same thing. So in a nutshell, the reason why you're installing the SDK is, well, not only to get to utilities that you're going to need to include these things in the packages that you're going to need to build the projects, but you're also getting the utility that does this. Takes the .java file, turns it into a .class file, which your Eclipse is going to do for you automatically anyway. Take the .class file and turn it into a .dex file, which is essentially the file that's inside of your .apk file. And as soon as we get through our first project, I'll show you what that is all about. It's just a package, installation package, which is kind of like an exe file from the old days. So what you're doing then essentially is compiling for a different JVM that's equivalent to the Java JVM. So let me come back to this underlying system here. And this, I like this picture because it's still, the architectural picture is still valid. And I don't know how many versions of the SDK we're through already since the creation of this, which was from the first version, 1.5. Still the same architecture. So what is the architecture? I'm sorry, do you have a question?
Yeah. So we can take the .dex file and run it in all the devices, right?
You could, but it's easier to take the .apk file that's created for it, which is an automatic application installation. So you click on it and it'll go ahead and install it for you. But you could theoretically take the .dex file, run it on anything that's an Android system, as long as it's compatible with the version of the Android that's on there. And I'll talk about that when we go through our first project. Alright, so what you're looking at is the underlying architecture that we're building for. So it's nice to see what we're looking at. It's a Linux kernel. Android is a version of Linux, which is a version of Unix, which works on the same concept. In fact, if you've ever taken away the GUI and watched your phone boot up, it looks like a Unix box booting up, actually. You'll see the same prompts. You'll see the same information showing up. It runs the same kind of scripts. It's just a different build. So you can actually download the source code for Android and build your own version of Android if you want to. If you're into building kernels, it's just like building another Ubuntu or Debian kernel. In fact, there's build utilities for it too. It's completely open source. So that's what a lot of people do, actually. So you're a computer manufacturer, you come up with a new device. Well, yeah, you need an operating system for your new device. So a lot of people have gone the Android route, especially with tablets and stuff. Because then you can build your own drivers, build your own kernel, load it on, and hello, you have an embedded systems environment that's running Android that's working on your proprietary hardware that you designed yourself, which is the route that a lot of manufacturers are going. So you see a bunch of tablets, phones, and things on the market, and sometimes they have their own unique build. No problem, that's just the underlying, that's just the foundation underneath everything else because it's a layered Linux foundation. As long as you load up the compatibility for the application framework, and the application framework is the same on all environments, well, relatively the same on all builds, then you have a platform that you can build applications. Your applications that you're building are up here at the highest level. It's being installed on top of the operating system. On the lowest level, closest to the hardware, is the Linux kernel. So you only have one Linux kernel, runs on the bottom. Go back to Unix or Linux 101. You're installing a kernel. The kernel loads up, installs everything else on top of it, loads all the modules. Very much a module system, actually, with libraries. So instead of having, we have a file system library. We have everything. We have camera libraries. We have libraries for practically everything on here. We also have SQLite. So we also have a built-in database on here, as well as a server. We also have internet access. Apache compatible, actually. You can write a TCP application, TCP/IP application for your Android device. Actually, you can do socket to socket, UDP and TCP, data exchange packages. through your Android device. You can treat it just like a Unix box, actually. In fact, some people do. You hook it up to a computer. You, if you want, for a bigger screen, bigger keyboard. You can install terminals on your Android device. Run, ls commands and Unix commands. It's a Unix box. A really small one, but it is a Unix box. So what do we get? On the bottom, I'm not going to go through everything, but just display drivers. This is close, the kernel build is closely tied to the hardware because we need the drivers for the camera, for the Wi-Fi, for stuff like that. On top of that, we're going to load our libraries. Our libraries are going to have the WebKit. Some people are familiar with that from the iOS environment. Kind of similar. It's the web, it's the HTTP protocol library interface. Our SSL, our OpenGL supports OpenGL just like the iOS device does. In fact, a lot of these libraries are very similar. They're just built for this kernel instead of that other kernel over there. We also have our Android Runtime environment. Well, that's the JVM or the DVM with our core libraries. And here's our virtual machine. So technically, I guess it was written on the slide. I could have just looked at it. The Dalvik virtual machine is the technical name for it. I have a tendency just to call it a JVM, but it's not really technically a JVM. It's a DVM, but it's working the same way. What does a JVM do? Which is kind of interesting. It runs one process at a time in a virtual environment. So we have some interesting, extremely interesting dynamics that go on the Android device that we don't get on some other devices. Yes?
SDK is built on Linux kernel.
The SDK is built on way up here on the application framework.
So where is the Linux kernel running?
As soon as the hardware boots up on the device, the Linux kernel initiates, just like a regular old computer would boot up Linux. And this is the underlying operating system, is the Linux kernel. The whole thing is actually included in the operating system, but it's very much a layered system.
So it is not involved during the development? Only when you implement.
Nope, you never touch the kernel. You can write your own kernel. You can write your own OS. But usually you're up here at the application level. Your SDKs are working up here. Your SDK is right here. Your application framework is right here, where you're going to get your view system. Actually, we're going to talk about content providers, view systems, window managers, and activity managers, starting out with activity manager. We're actually taking this as a layer-by-layer approach throughout this weekend. We're going to get through the entire application framework by the end of the weekend. Actually, we'll build things that use content providers, use the view system. View system is pretty easy, it's the layouts and stuff. And the next weekend, the next time I meet for the more advanced, we'll look at location mapping, notification, resource manager, telecommunications stuff, TCP/IP stuff like that, which is a little bit more advanced. So it's a nice little hierarchy. Most people are familiar with the systems from an application perspective. These are the phone utility, internet browser, address book. That's up here at the top of the applications. And in this course, we're writing applications that work on here. If this were an embedded systems course, we'd be writing the kernel, which is actually a little easier in my opinion, but it depends on your perspective. So, let's see. Also, part of the underlining architecture is the ability to add new modules and add new supports. Because it is an open system, you just add a loadable module. This is very much so a loadable module system. We also have the process concept that works with this, is what I was alluding to a few minutes ago when I said each program runs in a separate process. So we have this thing called an intent that we use to load multiple processes, which is a different running system than the iOS environment. So originally when this came out, people were saying, oh, this is slower because you got to switch between processes and you can't run more than one process at a time and blah, 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 blah. And there's no multi-processing, multi-switching. And then the iPhone supported multiple processes, multiple switching. Well, later, further down the road, we have utilities, and we're talking about comparing 1.5 with iOS. If you compare the current version, or even anything past 2.0, it's equivalent because of the new features in the SDK that allow for switching between processes and stuff like that. So the functionality grew, the functionality became very compatible. So here's our stack in terms of our application, software stack. So our applications here at the top provide a set of core utilities or applications for email, SMS, calendar, mapping, browsing. All applications are written in Java. So the application itself is nothing more than a Java program, and you're compiling it to go into the DVM correctly. Our framework, embedded simply for reusable components. So a lot of the times we're making instances of objects and we're including packages. So we include this package, we include that package, we include this one. We're making an instance of this object and we're using this object with that object over there and we're sending it. So it's very much an object-oriented kind of approach to programming. A lot more flexibility, in my opinion, for the project configuration than what you get in some of the other mobile device environments. So developers have full access to the framework. You don't like the API, you can change the API. In fact, you can download the API source code and change the way something is implemented. And the reason why you want to do that is because it's going to work with a specific piece of hardware that you have that might read it differently or might be optimized, or it might be optimizable. So users are allowed to replace components, which is an interesting thing that you get actually, because when you replace components, there's a warning. There's a security system on there. There's a warning you get when you install the app. And sometimes, depending upon that warning, somebody's not going to install that app. If it's going to, we're replacing your telephony component. Oh, no, wait a minute now. What are you going to do with that? Because it is an open source system, you can install something that could be potentially dangerous. So the way that the Android market has gotten around that is to, oh, you're going to put in these things, these little red warning signs when you install the app to say, hey, it's using the internet. Hey, it's using this. It's using your address book. It's using this. Most people just want to install it, so they're going to press OK on it. But theoretically, you're opening up the system. It's a very closed system, and you're opening it up when you allow those permissions. So I'll be talking about permissions today as well. Tons of permissions that are in the Android manifest file that we'll be looking at. So here's our application framework and the kind of the roadmap actually for today. Looking at the view system. So we'll start looking at the features in terms of the application development environment. The view system that's going to hold our lists, our grid, our text boxes, our embedded web browsers. So that's done in an XML format. Our menuing system is also done in XML. You don't have to worry about knowing XML actually, because there's a GUI component to it that will allow you to use a graphic drag and drop system rather than writing XML code. But XML code is not something to be afraid of, just like HTML code. There's a start and then there's an end tag. If you can handle HTML, you can handle XML. But instead of mocking up the look and appearance of the text, you're identifying the data and you're marking up. You're basically formatting data instead of formatting text. Very similar format though. Content providers will also look at that with the contents of the contact book with an app that we're going to build. Probably not, I don't know how far we're going to get, but before the end of the weekend we'll cover that. A resource manager as well, providing non-code resources. What is that going to be? Graphics, layouts, files. Keeping track of text files is really easy to use. Text files, Word files, a bunch of resources in that point of view. Notification manager, also reading and writing. I believe we'll probably hit that. Probably, hopefully by the end of this weekend, and if not, it'll be in the second session. Because notifications are a bit different because you have to know about the background services and things that are going on the phone. Activity manager, managing the lifecycle of applications. That's the first app we're going to build, actually. So looking at the libraries themselves, including a set of C++ libraries used for components on the Android system. The entire thing is written in C. It's an Android kernel. It's a Linux kernel. Written, compiled in C, but we're running Java on top of it. So it's like, okay, weird. Not really weird. We just have the framework built to interpret Java, and we've built it on top of C, C++ libraries. So you can actually use C and C++ libraries inside of it too. So inside of the Android device as well, actually. Composed to developers through the Android application framework. The whole thing is C, actually. So, well, Linux is C. Why wouldn't Android? Core libraries. What we're looking at here is providing the most functionality available for the core, data structures, utilities, file access. Think of these like the kernel loadable modules. Those are the core libraries. If you're building a Linux kernel, you have to decide what file system do I want. what kind of services am I going to provide? Am I going to have USB support? Am I going to have printing support? All of those are through the core libraries. So you include the core libraries in your project and you work away. So the Dalvik virtual machine is providing the environment for every Android application to run in. It has its own process. So each Android application runs in its own process with its own instance of the JVM, or the DVM I should say. So it's written such as the device can have multiple VMs running simultaneously. You also have the same thing with the JVM. If on your computer you can run multiple Java applications. The difference with that, however, is they're all running on the same JVM that's installed. And the JVM is managing all of the simultaneously running processes that you have. On the Android devices, for security reasons, each program is running in its separate instance of the DVM, completely isolated from everything else. Which means each process can have its own database, its own SQLite databases. It can access its own files, its own resources, and it can live on it's basically living on an island of its own. And if you're going to load up one view and you're going to use it, then you're going to use what's called an intent or another technique to load up a different view to change the application. So what you can do in this running process, which makes it, because most people when I say, it runs one process at a time, it does run one process at a time. But you can take your DVM, load multiple processes, and switch back and forth. But at one moment in time, you only have one process running. What do you really need? What does the user really want? You know? So you have one view, it doesn't follow the model view controller exactly like iOS does. You have one interface and you have one running program, and then you switch the interfaces to different interfaces, and you still have one running program by using intents and other techniques, which is what we'll be talking about in some of the projects that we're creating. In fact, Hello World, we're going to switch it. We're going to see this with Hello World, actually. So you create this intent. The intent's kind of like a pipe in the old Unix environment, where you send the output from one to the input to the other, and really you're going from one program to another program, but one of them's running first and one of them runs second, and you're kind of switching back and forth, and you can go back and forth because you can register the intents with the manifest. So, bringing up the concept of the manifest, and I'll talk about this a little bit more too when we run through our first program, but the manifest is the security guard. It's the traffic cop. It's controlling everything. It's controlling the permissions, the privileges. It's controlling which processes are allowed to run, which intents are allowed to be started, initiated, what data is allowed to go back and forth. It's your main configuration. So you mess up the manifest and your whole entire project's trashed. So actually it's determining which view is going to be loaded first as well, which XML view. So it's the security guard. Registered base virtual machine, and the registration is held by the manifest. So this is a picture we looked at before, relying on C. We have a thread, actually. Each process runs as a thread. We have low-level memory management that goes on in terms of that process. So here's our Linux kernel. Relying on Linux kernel 2.6 for the core system. It's a 2.6 compatible Linux kernel. Actually, I've seen people take these devices and load other Linux versions on it. They're hacked devices where you can, well, why not? You can get to it, no problem. It's not locked down. So it's just like a computer, just reformat the whole thing, put a different Linux kernel on it, and turn it into a Ubuntu box or something, if you want to. So it's open source. Memory, processing management, networking stack. Not a Unix course, so I'm not going to go through it. If you do have an interest in this, then what you really want to do then is take a Unix class and figure out how to build embedded systems, embedded Unix kernels. That's what you want to do. Android falls into the embedded department because of the fact that you don't have a monitor and a keyboard, but you do sort of have a keyboard on some of the devices. So you get stuff on here through the USB ports or through serial port access, kind of like you do on an embedded device. So it kind of fits into the embedded development platform. So this particular class is on the application development part. From the application, the highest level of abstraction. We will not be building Android kernels in here, but if you have an interest in that, I'm sure you can find something on that. It's pretty popular these days because everyone has new hardware and they need something to load on it. Okay, I think it's a good time to take a mini break for those people who need to use the restroom or to troubleshoot problems. So how about like maybe a 15-minute or so? 15, then because I really would like to start doing some stuff. So, and if you have problems, raise your hands.